Okay, guys, let's review for the part one of our test over radicals and powers. So we're going to add and subtract radicals, which means that the radicands have to be the same. So we're going to simplify our radicands. So we will use 4 times 3 for 12 and 16 times 3 for 48. The square root of 4 is 2, radical 3. Square root of 16 is 4, radical 3. You only combine the outside numbers, the coefficient, and we get 6 radical 3. Remember, adding and subtracting radicals is very similar to adding and subtracting like terms. You only combine the coefficients. Now we have 1/4, and we're going to break down 80 into 16 times 5. We're going to break down 20 into 4 times 5. When we take the square root of 16, we get 4, and 4 times 1/4. So we have 1/4 times 4, and the 4's cancel, leaving me with 1. And we can take the square root of a squared as well. And we get 1a radical 5 minus the square root of 4 is 2. The square root of a squared is a radical 5. So we have 1a minus 2a, so we get negative 1a radical 5. We're going to break down 8 into 4 times 2. We're going to break down 32 into 16 times 2. The square root of 4 is 2. 2 times 7 is 14, radical 2. The square root of 16 is 4. 4 times 1/2 is 2, radical 2. So again, 1/2 times the square root of 16, which is 4. 2 goes in a 4 2 times, and 2 times 1 is 2. So we get a total of 16 radical 2. Number 4, we're going to break down 98 into 49 times 2, x squared x minus 7. And we're going to break down 8 into 4 times 2, x squared x. The square root of 49 is 7. 7 times 2 is 14. The square root of x squared is x, leaving us with radical 2x minus. The square root of 4 is 2. 2 times 7 is 14. The square root of x squared is x, leaving radical 2x. 14x minus 14x is 0, radical 2x, and 0 times anything is simply 0. Okay, now multiplying, much easier in that you simply just multiply your coefficients and your radicands. Now, you can simplify the radicals first, but you do not have to. So if I'm working with a very large number that can be simplified, I will simplify first. But here we're going to just say 2 times 4 is 8, and 12 times 3 is 36. 36 is perfect. So I have 6 times 8 is 48 with no radical left at all. Number 6, 1/4 times 12 is 3. So we can quickly do this because when you multiply by a unit fraction, you're just dividing by that denominator. 4 into 12 is 3. 3 times 1 is 3. 8 times 3 is 24. A squared times a to the first is a to the third. We're going to break down 24 into 4 times 6, a squared a. We take the square root of 4, which is 2. 2 times 3 is 6. We take the square root of a squared, which is a, leaving us with radical 6a as well. Dividing, you're simply just going to simplify or divide your coefficients. 12 divided by 4 is 3. You're going to divide your radicands if you can, and we get radical 24. We can break down 24 into 4 times 6. The square root of 4 is 2. 2 times 3 is 6, radical 6. Number 8, 18 divided by 3 is 6. 80 divided by 5 is 16. K to the 6th divided by k to the 2nd is k to the 4th because we subtract. We're going to take the square root of 16, which is perfect. So 4 times 6 is 24. And k to the 4th is perfect. So we get k to the 2nd. Again, no radical left. Okay, let's calculate perimeter of this triangle. So perimeter is adding all sides. So perimeter is going to be 2 radical 18 plus another 2 radical 18 plus the base of 2 radical 8. Let's simplify these. 18 is going to be 9 and 2. And 8 is going to be 4 and 2. So the square root of 9 is 3. 3 times 2 is 6. Radical 2. Another 6 radical 2. And then we have the square root of 4, which is 2 times this 2 is 4. Radical 2. So now we only add our coefficients. So we're going to get 16 radical 2. Area is base times height. So our base is 2 radical 8 times our height. Divided by 2. Don't forget the divide. So I'm going to simplify these. So the square root of 8, so I'm going to bring it here. So let's come up here, area. So 8 is 4 times 2. The square root of 64 is perfect, so it's just 8 all over 2. We have the square root of 4, which is 2. 2 times 2 is 4. Radical 2 times 8 over 2. 4 times 8 is 32, radical 2, divided by 2, and you can only divide this 2 into this 32. You cannot divide a regular integer, whole number, into a radicand. So we're going to get 16 radical 2 for the area. Okay, let's simplify this. 108 36 times 3, C, D2, D2, D. We get 6D squared radical 3CD. So I'm going to mark out those things that I took a square root of and extend that radical sign. We are going to break down 72 into 36 times 2, E2E, F2. 36, the square root of 36 is 6, and 6 times 1/3 is just dividing by 3, so that's going to give us 2. Take the square root of E squared, take the square root of F squared, leaving us with radical 2E. This one, 3 can't go into 5. We can't leave a radical in the denominator, so we rationalize the denominator. So on the bottom, we get the square root of 9, a perfect square, which was the point. We can't simplify the square root of 15. It is simplified. And then we get the square root of 9, which is 3. Now, again, you cannot divide a regular number that's not a radical into a radicand. You cannot do that. This is your answer. On this one, we could simplify the 2/4 first, but let's go ahead and simplify. I'm going to come up here. And 48 is going to be 16 times 3 over 4. The square root of 16 is 4. 4 times 2 is 8. Radical 3 over 4. Again, I can only divide these, so we end up with 2 radical 3. Number 5, I noticed that this denominator is a perfect square, so I'm just going to go ahead and take the square root. I no longer have a radical in the denominator. I'm going to break down 24 into 4 times 6. The square root of 4 is 2, radical 6 over 12. But we're not finished because 2/12 can be simplified into 1/6. 2 goes into once and 2 goes into 12/6. I'm not going to put the understood 1, and I'm not going to divide this 6 into this radicand. They're two different types of numbers. Okay, let's simplify here. The square root of 25 is 5. The square root of d to the third is going to be d, and we have 1d left. Number 2, 144 is perfect. It is 12. The square root of 144 is 12. 12 times 1/3 means I'm dividing by 3, which is 4. The square root of f squared is f. No radical. Both of these are perfect squares. The square root of 324 is 18, and the square root of 100 is 10. I'm done, except I can simplify by a factor of 2, and I get 9 over 5, and just leave it at improper. Number 4, 81 is perfect. The square root of 81 is 9. 9 times 2 is 18, divided by 3, which gives us 6. Let's determine the perimeter and area of a rectangle. So let's do a quick sketch. So we can have 2 radical 48 and then the width 3 radical 27. So let's break down 2 radical 48. 16 times 3, which is going to give us the square root of 16 is 4. 4 times 2 is 8. Radical 3. We have 2 of these. So don't forget, you have 2. I'm going to break down 27 into 9 times 3. The square root of 9 is 3. 3 times 3 is 9. Again, we have 2 of these. So I can add 8 and 8, 16. 9 and 9 is 18. So 16 and 18. 6 and 8 is 14. So I have 34 radical 3. Okay, now let's do the area. So I know it's length times width. So I should put P equals here. Area is going to equal 2 radical 48. I've already broken that down into 8 radical 3 times 3 radical 27, which is 9 radical 3. 8 times 9 is 72 times 3 times 3 is 9. The square root of 9 is 3, and 72 times 3, 2 times 3 is 6. 3 times 7 is 21. So my area is 216 units squared. So what numbers have more than one factor that is a perfect square? So we've looked at these, like 48. We could break this down into 4 times 12, but we could have also broken it down into 16 times 3. Again, 16 times 3 is the most efficient one. I think we looked at 72. We know 9 times 8 is 72, but also 36 times 2. And of course, this one is the most efficient. So, and there are several more, but just be prepared to pick out some of the numbers that have multiple perfect square factors. So I hope this helps. Oh yeah, we need to go on to, okay, let's do a quick review of our power rules. So here we have multiplication. So we're going to use the product rule, but first we're just going to multiply coefficients like normal. Our base is v, and so we add exponents and we get 2 plus -6, and that's -4. So this -4 is attached to the v, so the 15 stays in the numerator, and v to the +4 is in the denominator. Our second example, we are dividing, but let's go ahead and simplify 12 over 18 by dividing by 6. And so that's going to give us 2/3. Our base is k, so I have 6 minus -3. We're going to use the quotient rule. When you're dividing like bases, you subtract top minus the bottom. Please write it out. And then when I'm subtracting, I do keep change, but only on subtraction. So that gives us a +9. So it's going to stay with the numerator. And so we're going to bring it with the 2. So 2k to the 9th over 3. Our third type is a power to a power. Every factor has an exponent, so write those in if they're not there. We're going to distribute the 2 to each exponent, and we have 4 squared h to the -6. We can evaluate 4 squared into 16, 4 times 4, and we're going to bring h to the -6 to the denominator, making it a +6. Again, we are multiplying, so we're going to use the product rule when we combine our base of b. But at first, we just have -5 times 2, which is -10. We have a base of b. We add exponents when multiplying, and we get a 0. We know anything raised to the 0 is 1. So this is really -10 times 1 because the 0 is only attached to the b, which gives us -10. Our next example, we are dividing. So we're going to have 16 divided by 4 is 4. We have 2 m's that can be combined, so I'm just going to write the m down. I'm going to apply the quotient rule, and I have 3 minus 5. This gives us -2. It is only attached to the m, so 4 stays in the numerator. We bring m to the -2 to the denominator, making it positive. Our last example is a power to a power. So we have 2 to the -2 and j to the first. We're going to distribute this outside power. We have 2 to the negative 6 and j to the third. We are going to move 2 to the negative 6 to the bottom, and we can go ahead and calculate that, and that is 64. And then j to the positive 3 stays on top. So I hope this helps.